Okay, so here we are in section 9.6, and in section 9.6 it's going to be all about dividing radicals. That's what we're going to be focusing on here. And you may recall I had given you a property involving the division of radicals, and we're going to focus on mostly square roots, actually exclusively on square roots. I know I originally gave you homework problems involving cube roots and fourth roots and higher root indexes, but when it comes to our dividing of radicals, we're only going to be focusing on now the square roots involving division. So you may recall the property that I had given you is that if we have the square root of a over b, first look to simplify, of course. First we want to simplify the fraction if possible. And then after you simplify the fraction, the square root of a divided by b is going to in fact equal to the square root of a over the square root of b. And then you would look to simplify each radical if possible. You're going to simplify the numerator, and then you're going to look to simplify the denominator, because we always want to express the radicals in simplest form. For example, let's say we have the square root of 25/49. Well, the fraction itself of 25/49 can't be simplified. There's no factor that goes into both 25 and 49 evenly. So what we would do is now use this property, and we would distribute the square root on the numerator, as well as we would distribute the square root onto the denominator. And what we get here, when we now simplify the square root of 25, is 5, over the square root of 49 is 7. And this would be your simplified answer. Okay. Let's try another one. Similar, if we were to take the square root of the fraction 12/27. Well, now here we can simplify this fraction. If I look at the fraction of 12/27, I recognize that both numerator and denominator are divisible by 3, in which case now we would have the equivalent simplified fraction of 4/9. By making the numbers smaller and more manageable, what we'll do now is we will use this property of dividing the square roots, and I will distribute the square root onto the 4, as well as I will distribute the square root onto the 9. When we take the square root of 4, we get 2. When we take the square root of 9, we get 3. So 2/3 would be your simplified answer. Now, you don't always have to eliminate the radicals. For example, if we have the square root of 24/25, once again, in looking at just the fraction, 24/25 can't be simplified. So now let's go and use that property and distribute the square root onto the 24, and then let's go and take the square root of the 25 in the denominator. Now, in the denominator we see here a nice perfect square, the 25, and when we take the square root of the 25 we get the nice rational number 5. And now let's take a look at the square root of 24. The square root of 24 can be simplified. Okay, not that 24 is a perfect square, but remember I can break it up using my factors of 4 and 6. And when we take the square root of 4, we get 2 square root of 6. And that would be your simplified answer. Okay, always look at even the numbers, the 2 and the 5. They are both outside the radicals. Always ask yourself, can they in fact be simplified? And no, they cannot. Okay? So what's left in the denominator is what we would call a rational number. The 5 is a rational number. The 3 that we had here is a rational number. The 7 that we had here was a rational number. Okay? In this numerator, we're left with a 2 square root of 6. This is considered an irrational number. And we like it when we have always a rational number in the denominator. That's how you know you have expressed your answer in simplest form, when you have a rational number in your denominator. And we're going to see some examples now where you're going to have to, what we call, rationalize the denominator. Now that doesn't mean we're changing the number itself, but we're going to just change the way the number looks. Okay, and we've done that quite a bit in the past. We have changed the way things look, but not changed their value. And you may recall, the only way to change the way a number looks without changing its value is to multiply by the number 1. And once again, we're going to have to do that here when we are looking to rationalize our denominator. For example, let's take the square root of 3/5. Okay? Now, the fraction 3/5 can't be simplified. So we will have to now go to use the property, and we're going to take the square root of the numerator over the square root of the denominator. So now we have the square root of 3 on the top and the square root of 5 on the bottom. Now, we can't simplify the square root of 3. We can't simplify the square root of 5. But that doesn't mean our problem is done, because we have a square root in the denominator. We never want to have an irrational number like the square root of 5 in the denominator. We have to rationalize the denominator. And here's what we're going to have to do. We're going to multiply by a form of 1. Okay, and the form of 1 that we're going to have to use in this particular problem is the square root of 5 over the square root of 5. Because you may recall in a previous lesson, I had said that the square root of a times the square root of a is going to equal simply a. And we're going to be able to use that right here. When I multiply the square root of 3 times the square root of 5, we get the square root of 15. When I multiply the square root of 5 times the square root of 5, well, if I use this idea here, the square root of 5 times the square root of 5 will simply be 5. Now we have simplified our answer, as well as we have rationalized the denominator. Okay, these fractions are equivalent to one another. Okay, this is in a more simplified and rationalized form. Let's try another example. Let's say we want to take the square root of 5/10. Well, in this particular case, here let's take a look at the fraction first. And the fraction 5/10 can be simplified. Both 5 and 10 are divisible by the factor 5, giving me 1/2. So now that I have simplified my fraction, I will now go and use my property, and now I will distribute the radical, and I'm going to take the square root of the top over the square root of the bottom. Now let's see if we can simplify. Well, the square root of 1, that's 1. The square root of 2, that can't be simplified. However, 1 over the square root of 2 is not our final answer. Once again, we must rationalize the denominator. I have to get rid of this square root of 2 that occurs in the denominator. So I'm going to have to multiply once again by a special form of the number 1. The form of 1 that we're going to use here is the square root of 2 over the square root of 2. Because once again, we know that any number divided by itself is the number 1. When we perform the multiplication, 1 times the square root of 2 is simply the square root of 2. And when we multiply the square root of 2 times the square root of 2, once again using this property, we simply get the rational number 2. And you can't simplify this any further. Don't think about simplifying here the 2 with the 2. You can't, because this is not really 2 in the numerator. It is the square root of 2, which is a completely different number. Let's try a few others. Let's say, for example, we have 10 over the square root of 6. Well, there's nothing that I can do to simplify this fraction. The only thing I have a problem with is the fact that there is a square root in the denominator, and we have to rationalize that. So let's multiply by a very special form of the number 1. This time, let's multiply by a square root of 6 over the square root of 6. When we perform the multiplication now, let's see what this would give us. This would give us a 10 square root of 6 in the numerator, and in the denominator, where we have a square root of 6 times a square root of 6, that simply gives us 6. But we're not done yet, because now once again, take a look at that fraction, see if there's anything that you can do to simplify. And sure enough, the 10 and the 6, we could simplify the 10 and the 6 because they're both outside the radical, and since they are both divisible by 2, that's how we would get a 5 square root of 6 over 3 as your simplified answer. Let me give you one to try, and let's see what you can come up with for your solution. I'm going to give you a problem, pause the video, work through the problem on your own, and see how you make out. Let's say, for example, we have the square root of, let's say, the fraction 12/80ths. What I'd like you to try now on your own is to simplify this as much as possible, expressing your answer with a rational denominator. So pause the video and come back when you're done. Well, if we were to, first of all, recognize that this fraction can be simplified, both numerator and denominator are divisible by the number 4. And that would give us now a square root of 3/20ths. Okay, so we have simplified the fraction, making the numbers more manageable and more workable. So now let's go and let's take the square root of the numerator over the square root of our denominator. Well, let's see if we could simplify anything here. The square root of 3, there's nothing we can do with that. So we're just going to leave it as the square root of 3. The square root of 20, however, that can be simplified. We can use the factors of 4 and 5. And so now what we would have here is the square root of 3 in the numerator, and in the denominator, when we take the square root of 4, we get a 2 square root of 5. Okay, so we have now simplified each radical, but now the problem is that we still have a radical in the denominator, so we have to rationalize that. Once again, we're going to have to multiply by a form of the number 1. And that particular form would be the square root of 5 over the square root of 5. Let's see what this is going to give us now. When we multiply the square root of 3 times the square root of 5, we get the square root of 15. Let's take a look at what's happening now here in the denominator. I have the number 2, and then I have this square root of 5 being multiplied with this square root of 5. Well, the square root of 5 times the square root of 5 is just 5. But don't forget, we also have to multiply it with the number 2 that was hanging around on the outside. And 2 times 5 would give us a 10. So our simplified answer would be the square root of 15 over 10. Okay, there's nothing more that we can do with that particular problem. We can't simplify our numbers. I can't simplify the radical 15, and 10 is already rationalized, so that problem is good to go. Let's do another one together. Let's say we have the square root of 2/45. Well, I can't simplify the 2 over 45. So I'm going to break this up into the square root of 2 on the numerator and the square root of 45 in our denominator. I look to simplify each radical now, and the square root of 2 can't be simplified, so we're going to leave that alone. The square root of 45, that can be simplified if I use the factors of square root of 9 and square root of 5. And so when we simplify further, we in fact would get, well, that the square root of 9 is 3 times the square root of 5. Well, we're not done with the problem yet, because once again, we have to rationalize this denominator. So once again, let me just rewrite the problem here. Square root of 2 over 3 square root of 5. So to rationalize this denominator, I'm going to have to multiply by the square root of 5 on the top and the square root of 5 in the bottom. That's the form of 1 that we have to use. When we perform the multiplication here in the numerator, the square root of 2 times the square root of 5, that gives us the square root of 10. Here in the denominator now, the square root of 5 gets multiplied with the square root of 5, and that gives me 5, times the 3. Well, 3 times 5 is 15. So our answer would be the square root of 10 divided by 15. You may be wondering, what if we have variables? Okay, for example, what if we have the square root of 5 over x? Well, first of all, we can't simplify the 5 over x. So what we would have to do is distribute that radical, that square root of 5 on the top, and the square root of x in the bottom. I can't simplify the square root of 5. I can't simplify the square root of x. But once again, we can't leave a square root, a radical, in the denominator. So just like over here, when we multiplied by the square root of 5 over the square root of 5, over here, I'm going to have to multiply by the square root of x divided by the square root of x. And so now if we multiply the numerator, the square root of 5 times the square root of x is the square root of 5x. And the square root of x times the square root of x is simply x. That, once again, eliminated the radical in our denominator. The last thing that I want to show you is a special case, because it's going to involve binomials. Okay. When we have a binomial, a two-term polynomial in the denominator, rationalizing the denominator is going to be a little bit different. For example, let's say we have the number 1 over 5 plus the square root of 3. Now, here, there's nothing to simplify as far as our radicals are concerned. The only thing that we have to do is we have to eliminate this square root of 3 in our denominator. And the only way that we're going to do that is to still multiply by a very important, a very special form of the number 1. Now here we have, as I mentioned, a binomial in the denominator. This binomial has a very similar binomial that has a special name, and it's called the conjugate. And that's what we're going to have to multiply by. Now, the conjugate will also be a binomial, and the first number will stay the same, as well as the last number will also stay the same. The only thing that's going to change when we talk about a conjugate is the sign that separates them. Okay? When you pick a sign, you always have to pick the opposite sign. So if it's a plus sign here in the original problem, that means the conjugate would have to be 5 minus the square root of 3. Okay? So once again, your conjugate, the first number is the same. The last number of the binomial is the same. The only thing that has to change is the sign that separates them. And since it's a plus sign here, we must use a minus sign here. Well, let's see what happens now. When I multiply the 1 times the 5 minus the square root of 3 in the numerator, we get just that, 5 minus the square root of 3. Now, here in the denominator, I have a binomial times a binomial. So what we're going to have to do is we will have to FOIL the conjugates. We're going to have to multiply these conjugate pairs together. So let's multiply the 5 with the 5. That gives us 25. When we multiply the 5 with the negative square root of 3, we get a negative 5 square root of 3. Next, we have to multiply the square root of 3 with the positive 5. That would give us a positive 5 square root of 3. And then the last thing that we have to do is multiply the positive square root of 3 with the negative square root of 3. That would give us a negative 3. Now let's simplify what we can. In the numerator, we're still going to have the 5 minus the square root of 3. In the denominator, I'm going to take the 25 and I'm going to minus the 3. Those are like terms, so let me combine them to get a 22. And the negative 5 square root of 3 and the positive 5 square root of 3 will in fact cancel each other out to 0. And so what that would leave us with now is a rationalized denominator. Okay, so here this was a special case because we were dividing by a binomial, and that binomial had a radical in it. Let's just do one more. Let's say we have 2 over the square root of 7 minus the square root of 5. Once again, the key here is to eliminate now both radicals. In the previous example, all we had was 1 square root, but here in this example, we actually have 2 square roots that we have to eliminate. So once again, we're going to have to multiply the numerator and the denominator by the conjugate. So we're going to keep the first number the same. We're going to keep the second number the same. Remember, when it comes to the conjugate, the only thing that's different is the sign that separates the two terms. So I had said to take the opposite sign. And since the original sign was subtraction, that means the conjugate sign will have to be addition. So now let's see what this will give us. Let's perform our multiplication now. In the numerator, I wouldn't recommend multiplying the 2. Leave it as 2 times the square root of 7 plus the square root of 5. There's no need to distribute that. Let's see what happens now when we once again FOIL the denominator. So we're going to FOIL these conjugate pairs. And if I multiply the square root of 7 times the square root of 7, we get 7. If I multiply the square root of 7 times the positive square root of 5, we get a positive square root of 35. If I multiply the negative square root of 5 times the positive square root of 7, we get a negative square root of 35. And then, lastly, if I multiply the negative square root of 5 times the positive square root of 5, we in fact get a negative 5. Well, keeping the numerator as it was, let's see what we can do to combine like terms in the numerator, the denominator. Here we have a 7 minus 5, that's 2. And we have a positive square root of 35 and a negative square root of 35. They will cancel each other out to 0. And so now let's take a look at this fraction. And I notice here that there's a 2 on the outside in the numerator, as well as a 2 on the outside in the denominator. So they can be simplified. And so now our best answer would be the square root of 7 plus the square root of 5. So that completes section 9.6, dealing with the division of radicals, keeping in mind that you always have to have a rational or a whole number in your denominator. You never want to leave it with a radical of any kind in your denominator.